2025 A-Level Combined Mathematics Paper 2 Part B Question number 15 Part B. Part A of this same question was discussed in a previous video, link in the top right. Part B of this question usually always has to do with Bose notation. This particular question says the framework shown in the figure consists of 5 light rods AB, BC, CD, DA and DB that are smoothly jointed at their ends. It is given that AB length is equal to AD length is equal to 2A and BC length is equal to BD length is equal to 2 root 3A and angle CBD is equal to 90 degrees or pi by 2 radians. Now given this, they say a load W is suspended at the joint C and this framework is smoothly hinged to a fixed point at A and kept in equilibrium in a vertical plane with BC horizontal by a force of magnitude P applied vertically upwards to it at the joint D. And given this, they say draw a stress diagram using Bose notation for the joints C, B and D, and hence find the stresses in the rods, stating whether they are tensions or thrusts. Now here, to start off, the first thing we're going to do is to take a look at the diagram, and we can see the diagram that they've given is missing a lot of information. It's missing the lengths of the rods and it's also missing the force at the point A. So if we go down, what we're going to do is to mark all the information that we know, and then we're going to start moving on to the question. So first off, we know that the length of AB is equal to the length of AD is equal to 2A. So going down, we can see the length of AB and AD, this length and this length are both 2A. So marking them down, 2A and 2A. Furthermore, we also know that the length BC is equal to the length BD is equal to 2 root 3A. So marking that down, here we have 2 root 3A and here we have 2 root 3A. Now finally, we also know that the angle CBD is pi by 2 radians or 90 degrees. So here looking at the angle CBD, we can see this angle here is 90 degrees. Now given this, we can find a bunch more information. So first off, if the angle here is 90 degrees, we can see inside of this triangle, we have a right angle triangle, which means that if you consider the ratios here, if we have 2 root 3A here, 2 root 3A here, and if we consider this angle, since opposite divided by adjacent is equal to 1, we can see that the angle here is pi by 4 and the angle on the other side is also pi by 4. So this angle here is also pi by 4. And additionally, the hypotenuse is going to be root 2 times the one of these side lengths, which is going to be 2 root 3A times root 2, which is going to be 2 root 6A. Now furthermore, looking at the triangle on the left, the ABD triangle, we can see we have 2A here, 2A here and 2 root 3A here. So therefore, this triangle is isosceles. Whatever angle we have down here, we also have over here. Now considering the angles, if we just divide the entire triangle here in half like this, we can see that this length is going to be root 3A and this length is also going to be root 3A, and the angle here is 90 degrees. Now given this, we can see if we consider this angle and the cosine value of the angle, the cosine value is 2 root 3A divided by 2A, sorry, not 2 root 3A, root 3A divided by 2A, which is going to be root 3 over 2, and therefore the angle here must be pi by 6, and we can say it's pi by 6 and not any other angle because of course it's in between 0 and 90 degrees. Now considering that if this is pi by 6 and this is also pi by 6, then we can also find the last angle here, this angle, and since this is pi by 3 and this is pi by 3, the total angle is 2 pi by 3. So we could just say pi by 3 here and pi by 3 here. Now finally, if we consider the force at the point A, since the other two forces are vertical and the entire system is equilibrium, we can see if the force at A was not vertical, then if you resolve horizontally, you would get not net force in the horizontal direction. You would not get an equilibrium condition. So due to this, we can say that by contradiction, the force at the point A cannot be horizontal at all, it must be only vertical. Now considering that there are two options, either it could be vertical downward or it could be vertical upward. Now consider the point C. If you take moments about the point C and you consider a vertically upward force, we can see about C, this force P is going to create a clockwise force like this, and the force here is also going to create a clockwise force, which means we don't have equilibrium. And therefore, again by contradiction, we cannot have a vertically upward force at the point A, and therefore the force at A must be vertically downward. So it must be something like this. Now we're going to call this force here R. Now with that, we have completed the diagram, and all we need in order to draw all of the Bose notation stuff is the value of P and the value of R, and after that we can continue to drawing Bose notation. Now finding P and R here is actually quite easy. All we need to do is to create a bunch of equations. First off, if we start resolving in the vertical upward direction, we can see we have P upward, R downward, and W also downward. So therefore, for equilibrium, we must have that P minus R minus W is equal to 0. And hence rearranging, P must be equal to R plus W. We're going to call this equation number 1. Now furthermore, if I want some other equations, I'm going to have to take moments, and I'm going to take moments about the point B. So taking moments about the point B, we can see since the force P is vertical and D and B are also vertical to each other, the force P passes through the point B. And therefore, we don't have to take any moments since the total moment about the point B due to the force P is equal to 0. Now considering the other forces that we have about the point B, we have a R here and a W over here. Considering the W, we can see the W is a distance of 2 root 3a, and it is going to create a moment in the clockwise direction. Therefore, the moment here is 2 root 3a times W in the clockwise direction, and if we take in the anti-clockwise direction, it's going to be minus 2 root 3aw. Now considering the other force, the force R, the distance relevant is this distance, which is going to be equal to 2a sine pi by 6, or just a. So therefore the moment here is a times r, since in the anti-clockwise direction is positive, so we have plus a times r, and that must be equal to 0, and we can see that this is going to give us that r is equal to rearranging 2 root 3w. So now with that we found the value of r, and furthermore from equation 1 we can see if we substitute this value of r, we can get that p is equal to 2 root 3w over here plus w, which if you take out the w is going to be equal to 2 root 3 plus 1 times w. So we can write down here 2 root 3 plus 1 w. So with that we found the value of p and the value of r, and now finally we can move on to doing the Bohr notation. So for Bohr notation, as you know, what we need to do is to first divide our system into a bunch of regions based on the forces. We need to divide each of the regions in between forces and call them separate labels that we can use later. So after that, what we're going to do is to use these regions to label the forces and construct a vector space using those regions, which we can then use to find unknown forces. So to start off, if I call this region here region number 1, I can start going in the anticlockwise direction, and as I go outside in the anticlockwise direction, we can see we are going to eventually have to pass the force W. We can see since the line of force W goes like this, we are going to have to eventually pass the force W, and as we do, we are entering a new region, and I'm going to call this region region number 2. So going over here, I'm going to call this region region number 2. Now again going outside externally in the anticlockwise direction, I can see going from region 2 like this, I'm going to have to eventually pass the force P, and passing the force P I come into new region here, which I'm going to call region number 3. Now I cannot actually do this again because you can see if I try to go anticlockwise again and pass the force R, we are back in region number 1, and therefore we are done marking all of the external regions. So now that we're done with the external regions, let's move on to internal regions. We can see in this diagram we have two internal regions. This internal region here inside of the triangle BCD, and this internal region here inside of the triangle ABD. So considering them, I'm going to call this one region number 4 like this, and I'm going to call this region region number 5. And with that we can see we have completed this diagram because we have marked all of the external and internal regions. So now finally we can start making our Bose notation diagram. So to start with Bose notation, as you know, what we need to do here is to consider different points in the system and take forces in either the anti-clockwise or the clockwise direction around each of those points and use that to slowly build up our Bose notation diagram. Now remember, we have to always take in the same direction. If we choose anti-clockwise, we need to take anti-clockwise in all of the points, and if we choose clockwise, we need to take clockwise in all of the points. Now, as they said, we have to use the points C, B, and D. They haven't mentioned A here, which means probably we can get away with not using A. We might also just draw A just for the fun of it, but we don't really need to do A. So let's consider C, B, and D, and let's also consider them in the order that they've given us. Let's start with C first, then go to B, and then go to D. So by preference, I'm going to do in the anticlockwise direction. So considering the regions around the point C going the anticlockwise direction, if I start with region number 1, which is this region, and I go in the anticlockwise direction around the point C, I can see going from region 1, the next region I'm going to go to is region number 2, and to go there I needed to pass through the force W. And we can see the force W is in downward direction. So therefore, according to Bose notation, if I convert this into a vector space, then considering the points 1 and 2, going from 1 to 2 in the vector space is going to correspond to a downward motion of magnitude W. So therefore, if I go down and start my Bose notation diagram, and I label a certain point and call that point 1 corresponding to region number 1, then region number 2, as we saw up here, must be a W distance down from region number 1, since going from region number 1 to region number 2 in this diagram required us to go through a downward force of W. Converting that to the vector space, we can see going from the point corresponding to region number 1 in the vector space, we must go down a distance of W in order to go to the point corresponding to 2. So therefore the point 2 is over here, and we can see we have gone down from 1 to 2 by a distance of W to go from region 1 to region 2 in the vector space. So now, if we move on from that, the next force we're going to consider is going to be, again, of course, we have to start from region 2, and going from region 2 around the point C in the anticlockwise direction, we have to go through this rod here, the rod DC, and therefore we need to consider the force in the rod DC. Now, since the rod DC was weightless, we know that the force through rod DC must be traveling in the direction of rod DC, since if it was not, then we would have some net moments and other stuff about the rod DC. So due to that, we can say that the forces inside the rod DC must be traveling in the direction of the rod DC. Now the rod DC has a direction of pi by 4 to the horizontal, and therefore the force through this rod must be in that same direction of pi by 4 to the horizontal. Now considering that, if we consider the implication of the vector space, we can see since we are going from region number 2 to region number 4 in this diagram, and we have to pass through this rod, the corresponding line in the vector space from region number 2, or the point corresponding to region number 2, to the point corresponding to region number 4 must be in the direction of this rod. So going down, if we consider region number 2, region number 4 relative to region number 2 must be in the direction of the rod, which is this direction right here, where this line that I've drawn here, the dotted line that I've drawn here, is at an angle of pi by 2 to the horizontal. So sorry, pi by 4 to the horizontal. So if I draw that out, it's an angle of pi by 4 like this to the horizontal, pi by 4. So now going up, if we consider the final set of regions here, going around C in the anticlockwise direction, we're currently in region number 4, and if we go in the anticlockwise direction around C from region number 4, we can see we have to pass through the rod BC. Now since the rod BC is also weightless, we can say that the force through the rod BC is also in the direction of the rod BC. Now due to this, going from region number 4 to region number 1, we can see in the vector space the line corresponding to going from point number 4 to point number 1 must also be horizontal. So going down, we can see if we consider going from 1 to 4 or 4 to 1, it must be in the horizontal direction, and therefore we can draw a horizontal line through the point 1, and we know that the point corresponding to 4 must be on this line. So with this, what we know is that the point corresponding to region number 4 must be on this dotted line, and it must also be on this dotted line, and therefore it must be on the intersection of the two dotted lines, which is this point right here, and therefore the point corresponding to region number 4 must be this point right here. And just like that, we have found the point corresponding to region number 4. The angle here is pi by 4. Since this is horizontal and this is vertical, the angle here is 90, and the angle here is also pi by 4. So now that we found the point 4, I'm going to erase the dotted lines and I'm going to replace them with straight lines. So doing that, we can see we now know the location of point number 4, the region, the point corresponding to region number 4. Now moving on from that, if we then consider a different point, since we've done all of the forces around the point C, considering a different point, let's say according to their order it was B, so let's say B. Considering B, if we go in the anti-clockwise direction, we can see the first thing we have is going from region number 1 to 4, which we already did. We know what that's going to be. So now after that, going from 4 to 5, we can see going from 4 to 5, we have to go in the vertical direction since the rod in between these two is vertical and it is weightless. So considering rod DB, going from region 4 to 5 must be vertical. So therefore, in our Bose notation diagram, we can draw a dashed line or dotted line through the point 4 that is going to be vertical, and we can say the point corresponding to region number 5 must be also on this same line. So if we just put this thing and we align it with point number 4 like this, we can say that point number 5 must be on this line. Now moving on, considering the next set of regions that we have, the next set of regions going in the anti-clockwise direction round B is going to be going from region number 5 to region number 1 again. So going from region number 5 to region number 1, we can see again we have to pass through a rod. The rod is AB, and since the rod is weightless, once again the force is going to be in the direction of the rod, and considering that the angle here is pi by 3, the angle here is pi by 6, and therefore the force corresponding to this rod, and therefore the line corresponding to region number 5's point to region number 1's point must be at the same angle. So going down, if we draw this in this diagram here, we can say going from region number 1 to region number 5 or region number 5 to region number 1 must be at that same angle. So if we draw a dashed line or dotted line, we can go through the point 1 at that same angle, which is approximately this angle. It doesn't have to be exact, but it's approximately that angle. Going like that, we must have the point corresponding to region number 5 somewhere on this line. Now we can see if I expand these two, I've actually run out of a bit of space. I need to bring the entire diagram down here to get the correct space. So if I do that, bringing the diagram down here, you can see since the point corresponding to region number 5 must be on this line and this line at the same time, we can say that it must be at the intersection point of the two lines, and therefore if I zoom in, we can say that the point corresponding to region number 5 must be this point right here. So I can just mark that out. It is going to be this point right here. So this point is corresponding to region number 5. Now that we've done that, we can erase the dotted lines and replace them with straight lines. So doing so, we can see we've now found region number 5. It is this point right here, and we can connect these two, and we can also mark the angles here. We know that the angle to the vertical here was pi by 6, and therefore the angle here is pi by 3. And of course, since this is vertical and this is horizontal, the angle here is 90 degrees. Now moving on, the final point that they've told us to consider is the point D. So considering the point D, we can see going around the point D, let's say we start from region number 4, we then have to go around D like this, and we go to region number 2, which we already marked, so we don't need to mark it. But then after that, we need to go from region number 2 to region number 3, and going from 2 to 3, we can see we have to go across the force P, which is in the vertical upward direction with this magnitude. So going from 2 to 3, we can see we have to go by 2 root 3 plus 1 W, and going from 2 to 3 in the vector space, we can see we can go upward by a distance of W, which means that after that we need to go an extra distance of 2 root 3 W, and therefore the point corresponding to 3 must be 2 root 3 W distance above the point corresponding to 1, and therefore it must be vertically upward like this at a distance of 2 root 3 W. Now considering the final equation, if we go from region number 3 to region number 5, we can see we are going in this direction, which means we need to draw a line in this direction from point 3 to point 5 or point 5 to point 3. So considering that the angle here is pi by 6, if I go down and mark that, from region number 5 to region number 3, we must be going in that direction. I can actually see I've also again run out of space. So to take this a little bit down again, so we're taking it down like this. The angle from 3 to 5 must be pi by 6 with the vertical, pi by 6 with the vertical, and therefore it must be something like this. If I draw it in dashed lines or dotted lines, it's going to be like this. So therefore we can see, if I take this line and I extend the line that I drew through the point 1 like this, we can see that they're going to intersect at this point right here. So therefore this point must be the point corresponding to region number 3. So therefore this point is corresponding to region number 3, and I can erase the dotted lines and then also this extra part of this line, and then I can mark the point 3 like this. So therefore the point corresponding to region number 3 is this point right here. And now, since we marked all of the regions, or rather I should say all of the points corresponding to all of the regions, we are actually done with this Bose diagram. So all we have to do now is to simply mark all the angles and lengths, and we'll be done, and we can finally answer the question. So considering this angle here, the angle here was pi by 6. Going down, we can see if this length here is w and the angle here is pi by 4, if I mark that angle actually pi by 4, then the length here is also w. This is root 2w since we have pi by 4 here, so this is root 2w. Considering the rest of the angles and lengths, if this is w and this angle here is pi by 3, then the tangent of pi by 3 is going to be equal to root 3, and therefore this length divided by w is going to be root 3, and therefore this length is root 3w. Moving on, the hypotenuse here is going to be equal to, if we consider root 3w squared plus w squared, is going to become 4, and therefore this is going to become 2w, so 2w. And then finally, considering the rest of the angles, if this is 2w, since this whole thing is symmetrical as this angle is also pi by 6, we can say that the other length here is also going to be 2w. And finally, if this is 2w, this is 2w, this is pi by 6 and this is pi by 6, we can say, cutting this in half, this must be equal to root 3w, and therefore the total length here is 2 root 3w. And with that, we have completed our diagram. So now finally, we can answer the last question, which is to find the stresses in the rods, stating whether they are tensions or thrusts. Now considering that, what we need to do is to find the regions corresponding to each of these rods, and by using that, we can find the corresponding forces. So considering the regions here, we can write AB rod, BC rod, BD rod, CD rod, and AD rod. So considering those rods, for AB rod, the regions corresponding are 1 and 5. For BC rod, the regions are 1 and 4. For AD rod, the regions are 3 and 5. For BD rod, the regions are 4 and 5. And for CD rod, the regions are 2 and 4. So if we go down, we can construct a little table that contains all this information, and we can quickly fill in all of that. So if I just do that real quick, and done. So there we go. This is the kind of graph that you'd be expected to draw, and in this graph you can see there are 4 columns. There's the rod column, the regions column, and then there's 2 columns, thrust and tension. So in the rod column, you are expected to write the 2 letters corresponding to the rod, either AB, AD, or so on. And then in the regions column, you are expected to write the 2 regions corresponding to the force inside of the rod. So either, let's say for AB, if the regions are 1 and 5, then you write 1 and 5 here and AB here. And after that, we have 2 columns, thrust and tension. So the force in each of the rods is either going to be a thrust or a tension. So if the force is a thrust, then you are going to write something in the thrust column, and then you're going to leave the tension column blank. And if the force inside of rod is a tension, then you're going to write something in the tension column and leave the thrust column blank. And by doing this, you're going to fill in all of the information relevant to the question. So going up, if you start filling this table, for the rod, we have a total of 5 rods. We have the rods AB, AD, BC, BD, and CD. So writing these down, we have 5 rods AB, AD, BC, BD, and CD. Now considering the regions corresponding, for AB and AD, if we go up, AB and AD, for AB, the 2 regions on either side are these 2 regions, which is region 5 and region 1, so 1 and 5. For AD, if we consider, it's this rod, so the regions are these 2, which are 3 and 5. So therefore, for AB, we have 1 and 5, and AD, we have 3 and 5. So going down, if I mark that, for AB, the regions are 1 and 5, and for AD the regions are 3 and 5. Now for BC, BD and CD, if we go up and check BC, for BC the regions are 1 and 4, for BD the regions are 4 and 5, and for CD the regions are 2 and 4. So if I just memorize that real quick, 1 4, 4 5 and 2 4. So going down, the regions for BC are 1 4, and then for BD they are 4 and 5, and for CD they're 2 and 4. So now that we have this, we can finally find the forces in each of the rods. We can find them by the fact that the magnitude of the force is going to be equal to the distance between the 2 points in the vector space corresponding to the 2 regions corresponding to each of these rods. So for the rod AD, for example, the magnitude of the force in the rod AD is going to be correspondent to the distance between the points corresponding to 3 and 5 in the vector space. Now, as for whether it's a thrust or a tension, what we need to do is to go up and consider the direction of the forces. So if we take an example, let's say AB. For AB, the regions are 1 and 5. So going up, if we consider 1 and 5 and the rod AB, let's say we take the point A. So for the point A, considering the regions 1 and 5, for the rod AB, since we drew the diagram taking forces in the anticlockwise direction, here as well, we need to take forces in the anticlockwise direction. So considering the rod AB, if we go in the anticlockwise direction about the point A, we can see for the force inside of AB, we need to go in the anticlockwise direction from region 1 here to region 5. So therefore, we need to go from 1 to 5 from the perspective of the point A. Now going into a Bose notation, we can see going from 1 to 5 in the vector space is 1 to 5, which is in this direction. It has a magnitude of 2W and is in this direction. So we can see the force is going to be 2W in this direction. Now that force of 2W is the force experienced by the point A. So if the point A experiences a force of 2W like this, then the rod AB is going to experience an equal and opposite force in the opposite direction. So therefore, if the point A experiences a force of 2W in this direction due to rod AB, then rod AB is going to experience a force in this direction of magnitude 2W at the point A. Now similarly, by symmetry, at this end, the rod AB is going to experience the same force of 2W, but now in this direction. So it's going to experience in this direction. Now you can see, if we are pushing the rod AB in this direction at this end, and we're pushing it by same force of 2W in this direction at the end B, then what we're doing is crushing the rod. You can imagine a force of 2W on one end pushing the rod in one direction, and another force of 2W in the other side pushing the rod in the other direction. So we can see what we're doing here is compressing the rod. So if we are compressing the rod, then the rod is under thrust, and therefore we can go down to the table and write that the thrust here is of magnitude 2W, and therefore for the rod AB, we can say we have a 2W thrust, and it's not a tension, so we can mark that blank. Now for the next one, if we consider AD, the regions involved are 3 and 5. Going through 3 and 5, we can see for regions 3 and 5, if we consider, let's say, we'll choose A again. So for A, going in the anticlockwise direction, for the regions 3 and 5, for the rod AD, we need to go in the anticlockwise direction from region 5 to region 3. Now going from 5 to 3, we can see from 5 to 3, the force is again 2W, but this time it's in this direction. So now, if we consider that force in that direction, this force is the force experienced by the point A from the force corresponding to AB rod, or rather AD rod I should say. So for AD rod, at the point A itself experiences a 2W force in this direction. So considering that, if the point A is experiencing a force of 2W in this direction, then the rod AD must be experiencing an equal and opposite force in the other direction. So therefore, the force in AD at the point A is going to be like this, and similarly at the point D it's going to be like this, and the value here is 2W and 2W. Now we can see, as it appears, the forces on the rod AD are pulling it apart. The force at the point A on the rod AD by the point A is pulling it apart in this direction, And at the point D, the force on the rod AD by the point D is pulling it apart in this direction. So therefore we have a pulling force here, which means that the rod AD is under tension and the tension is 2W. So therefore going down we can mark that rod AD is under a tension of 2W and has no thrust, because of course it has a tension instead. So now continuing for the other three, if we can actually do this quickly, since now I think you probably get the pattern. Going from BC, we have regions 1 and 4. Going to 1 and 4 in region BC, let's say we choose B. So choosing B in the anticlockwise direction, we can see we have to go from region 1 to region 4. 1 to 4 in the diagram is in this direction. So therefore, the force experienced by the point B from the rod BC at this point is in this direction. So therefore, the rod itself, the rod BC, is going to experience an equal and opposite force, which is going to be in this direction. And on the other side, it's going to experience a force like this. So we can see if the force on the left is pushing rightward and the force on the right is pushing leftward, the rod is being crushed, it's being pushed inward, and therefore it's being compressed and it is under a thrust. Now going down for the regions 1 and 4, we can see the thrust corresponding is of magnitude W, and therefore going down, the rod BC is experiencing a thrust of magnitude W and not experiencing a tension. Now next for BD, we have 4 and 5. Going up, if we consider 4 and 5 and BD, we can see, let's say we take B again. So taking B again in the anticlockwise direction, we have to go from 4 to 5 like this. So 4 to 5 in the diagram is 4 to 5 in the diagram is upward. It has root 3W value. So therefore we have upward force of root 3W at the point B due to the rod BD. So if rod BD is applying an upward force, then the point B must be applying a downward force on the rod BD. So therefore the rod BD is being pulled downward by the point B, and similarly at the point D, it's being pulled upward. So now, if the rod is being pulled downward at the bottom and being pulled upward from the top, it is being pulled. It's under tension. And the value of the tension is root 3W. So therefore, rod BD is under tension and the value of the tension is root 3W. So therefore, we have root 3W here and no thrust. Now going down, finally, we have CD. CD is corresponding to 2 and 4. Going up, 2 and 4, we can see if we take C, the point C, we're to go anticlockwise from 2 to 4, and going from 2 to 4 in the diagram, we can see 2 to 4 is in this direction, so 2 to 4 upward like that. So therefore the force experienced by the point C from the rod CD is in this direction, meaning that the force experienced by the rod CD from the point C is in this direction, and similarly the force experienced by the point D from the rod is going to be in this direction, and therefore the force experienced by the rod CD from the point D is in this direction, and we can see on this side is being pulled that way, on the other side is being pulled the other way. So the rod here, the rod CD, is being pulled apart, and therefore it's under tension, and the value of the tension corresponding to 2,4 is root 2W, and therefore we have a tension of root 2W. So going down, we can say we have root 2W tension and 0 thrust. And with that, we have finished the entire question. So now finally, let's discuss the marks awarded for this question, which is actually quite simple. So at the start, when you draw all of this, you actually don't get all that many marks for this thing. What you do get marks for is the Bose notation that you create from this diagram. Now you still need to get everything correct here, but you don't actually get any marks for this part. Instead, down here for the Bose notation, if you've drawn all of the points corresponding to all of the regions correctly, and you marked all of the magnitudes of all of the forces correctly, then you get a total of 30 marks for the entire diagram. So of course here you can see, considering the forces, we have a total of 1, 2, 3, 4, 5, 6 and 7 forces, and we have a total of 1, 2, 3, 4, 5 points, and we have a bunch of angles. All of this needs to be right in order for you to get this 30 marks. Now you get the 30 marks based on the triangles here. You get 10 marks for getting this triangle correct, you get 10 marks for getting this triangle correct, and you get 10 marks for getting this triangle correct. So now after that, finally for this part, when you write down all the tensions and thrusts here, if you've written down the regions and everything correctly, for the first parts, you get 5 marks each, 5, 5, 5, 5, and 5. And for the second part, where you write the tension and thrust and you mark it correctly, if you mark the thrust correctly and the value correctly, or the tension correctly and the value correctly, you get another 5 marks here. So 5 marks, 5 marks, 5 marks, 5 marks, and 5 marks for a cumulative 50 marks. So you get 50 marks there and 30 marks here for a total of 80 marks for this simple question. So that's going to be all for this video. I hope you enjoyed. If you have any feedback, post them in comments down below. Thank you for watching and goodbye.